Hi, I am Artem Chebatko and this is Introduction to DSE GraphFrames. DSE GraphFrames is an alternative OLAP engine for DSE Graph. It is designed around our DSE Analytics offering, and it enables a unique way of interacting with DSE Graph using various Spark APIs and tools. You can think about a DSE GraphFrame as a representation of your graph in Spark. And this representation is actually based on the original notion of GraphFrames in Spark. We will soon learn more about specifics of DSE GraphFrame based on our killer video graph example. There are various ways you can work with the DSE GraphFrames. You can use a subset of Gremlin to define OLAP graph traversals. There is also a complementary DSE GraphFrame API that is primarily used for bulk mutations. You can search for structural graph patterns using the original Spark GraphFrame API. Finally, you can use any other Spark API that may be suitable for your application. That includes Spark SQL, DataFrames, and Spark Streaming, just to name a few. When it comes to DSE GraphFrame use cases, there are many, due to the versatility and power of this OLAP engine. Of course, you can do Gremlin traversals, just like in the other OLAP traversal engine based on the Spark graph computer. But DSE GraphFrames are unique as they also support non-Gremlin graph data manipulation and accessing data directly from Spark. As a result, you can combine data stored in DSE Graph with data stored in Cassandra, with data stored in a relational database, with data stored in a file, with data coming in a stream, and so forth and so on. With this kind of power, there are virtually unlimited possibilities for the type of analysis you may need. It is also worth mentioning that DSE GraphFrame is currently the most efficient way to do bulk loading and bulk mutations in DSE Graph. If you have an existing graph data set that you want to load into DSE Graph, DSE GraphFrames is the way to go. Let's create our first DSE GraphFrame in Spark Shell. To do that, we start Spark Shell by executing command DSE Spark, and then call the DSE Graph method of the Spark session object with the name of the graph as a parameter, killer video in this case. We assign the result to G, which is an instance of DSE GraphFrame, as you can see in the output. While it is convenient to think about a DSE GraphFrame as simply a representation of a graph stored in DSE Graph, there is a bit more to it. Internally, in Spark, a DSE GraphFrame is represented by two virtual tables or data frames, one for vertices and one for edges. The Vertex data frame has columns for vertex ID, label, and properties. The edge data frame has columns for source and destination vertex IDs, edge internal ID, label, and properties. It is important to notice that even so, vertex IDs in DSE Graph can be composed of values from multiple properties, the DSE GraphFrame representation always serializes a vertex ID as a single value through hashing and concatenation. This is done on purpose to make the DSE GraphFrame format fully compatible with the original Spark GraphFrame format, so that you can take a full advantage of various Spark APIs. In general, this ID conversion is done implicitly and automatically, but we will also learn how to do it explicitly, which will be useful in some cases. In the context of our killer video graph, this is how the vertex table schema looks like. G is our DSE GraphFrame. We call its method V to get the vertex data frame, and then DataFrames method print schema to output the result. We see columns ID, label, user ID, age, gender, genre ID, name, person ID, movie ID, and so forth. The production column is a bit unique as it corresponds to a multi-property and its data type is the array of strings. Based on the columns, you can see that this data frame is used for vertices of different types. In our case, users, movies, people, and genres. Using DataFrames method show, we can take a look at the actual column values in the first 5 rows. We have rows corresponding to user U185, genre adventure, person Johnny Depp, and 2 Alice in Wonderland movies. Similarly, we can output the age data frame schema for the killer video graph. It does look simpler because we only have one age property called rating, and it is of type int. And you may remember that source and destination are columns that store age, source, and destination vertex IDs. An ID is a column that stores edge IDs that are generated and used internally by DSE Graph. Here are some concrete values to look at. Besides the label and rating, there is not much for us to comprehend. Finally, we conclude this presentation with the summary of DSE GraphFrame APIs that we cover in more detail in subsequent videos. First, we have Gremlin API to define Gremlin traversals starting with either method V or method E, followed by traversal steps like in, out, count, and so on. We assume that you are already familiar with the Gremlin traversal language. Second, there is Spark GraphFrame API that, among other things, has some interesting structural pattern matching capabilities. In Scala, DSE GraphFrame is converted to Spark GraphFrame implicitly. Explicit conversion is done using the GF method. Third, we have very efficient methods for bulk mutations. We can insert, update, and delete graph elements with those. And last but not least, we have the data persistent methods cache and persist, which you may already be familiar with since they have the same purpose as similar methods available in Spark.